Okay, YouTube, this is my second video using sum and difference formulas in which we're going to do two things. We're going to use the sum and difference formula not to evaluate for the trig function of an unknown angle using the composition, either a sum or a difference of two known angles, but we're going to simplify an expression that contains a difference inside this angle quantity here. And we're going to use a cosine sum or difference formula in this video. Last one we used a sine sum or difference formula. So I want to simplify this expression, excuse me. So we have the cosine of some angle minus 3 pi halves. How could we rewrite this otherwise? And so using our cosine here, sum and difference formula, a little bit different from sine, you'll notice that we're going to need to know the two parts u and v first of all. So in this particular instance, our u is like our angle theta in general, and our v is this 3 pi halves. Notice that I didn't write negative 3 pi halves. We'll just say that u and v are these things, and they are in a difference with one another, okay? Also this, when we talk about a cosine sum and difference expansion, notice that when we did the sine, it was sine, cosine, and that if we had a plus minus here, we had a plus minus here. When we use a cosine sum and difference formula, it is just cosine, sine. And also u and v maintain kind of their spots, uv. It is just that instead of having a plus minus here and a plus minus here, we have a plus minus here and then we have a minus plus here. So this is going to be the opposite of what we started with over here. In terms of what we have over here, we have a difference. So when we rewrite this, we are going to write it is cosine u, cosine v. And this time, instead of having a minus here and a minus here, we'll have a minus here, but then a plus here since we're using a cosine sum and difference formula. So we have a sine u and a sine v, and we're going to use this to simplify this expression here. So in this particular instance, we said our u was like this theta here. So we say u, our v is 3 pi halves. Oops, write that a little bit more cleanly. 3 pi halves. Then we have another theta and another 3 pi halves. And so simplifying this, well, cosine theta is just cosine theta, but in terms of what is cosine of 3 pi halves, I mean, we can visualize this here. A pi half is here, 3 pi halves is down here, and we say, well, what is the cosine of 3 pi halves? So we can refer to the unit circle, or we could say, well, look, the unit circle has a radius of 1, and this is the point 0, negative 1 down here. So for instance, what we get here is cosine of 3 pi halves, the cosine value is 0. So we get simplified, at least, we have cosine of theta, which did not simplify at all, times a value of 0. Plus now the sine of theta, and the sine of theta times the sine of 3 pi halves. Down here the sine of 3 pi halves is negative 1, so we get a negative 1 here, negative 1. So this term here is going to cancel out completely, and we see that we get just negative sine of theta. So it is perfectly accurate to say that this original statement here, if I said, hey, go prove that the cosine of theta minus 3 pi halves is actually equal to the sine of theta, negative sine of theta. We could have done this just by using a sum and difference formula right here, but essentially we're able to simplify this expression right here. Cheers.